Okay, in this video we're going to look at an introduction to square roots. Okay, so here's page 1, and we'll go over these examples. Okay, page 2 we'll do these examples, and page 3 we'll do these examples. Okay, are these equations true or false? So page 1, please with your pen and paper write these out. 1 squared all the way to 13 squared, and calculate each one of these. So you've got to get familiar with all the regular perfect squared numbers. Okay, very important. Get familiar with all these. So 1 squared is 1 multiplied by 1, which is 1. 2 squared is 2 multiplied by 2, which is 4, right? 3 squared is 3 times 3, which is 9. Okay, so fill them all out, all the way to 13. And okay, so what you need to do is press pause on the video, calculate each one of these. Okay, yourself, got to calculate them on yourself, and then check the video to see if you get them all the same. Okay. Okay, so please press pause and calculate each one of these. All right. Okay, I'm going to do it now. 4 squared is 16, 5 squared 25, 6 squared 36, 7 squared 49, 8 squared 64, 9 squared 81, 10 squared 100, 11 squared 121, 12 squared 144, and 13 squared 169. Okay. So these are, the most common squared numbers, and what we want to do is have a look at square roots. So if you were asked for the square root of 4, what that's saying is what positive number times itself gives 4? What number times itself will give you 4? And the answer is 2, right? If you were asked for the square root of 9, that's asking what number times itself gives 9. 3 times itself gives 9. If you're asked for the square root of 16, what times itself gives 16? 4, right? So let's mix them up a little bit, and you can block your squareds up there. And what about root 49, root 64, root 121, root of 25? Okay, what do these give? And root 1. What number times itself gives 49? What number times itself gives 64? What number times itself gives 121? What number times itself gives 25? And what number times itself gives 1? And just for fun, at the end of that, please do this one. Square root of 0. So if you need more time, please press pause on the video and write these answers out. There's no point just copying them off. You've got to figure them out yourself, okay? So please press pause in the video and figure them out. Okay. So how's it going? Root 49, 7. Root 64, 8, isn't it? Root 121, 11. Root of 25 is 5. What number times itself gives 1? The answer is 1, because 1 times 1 gives 1. What number multiplied by itself gives 0? Any idea? The answer is 0, because 0 times 0 gives 0, doesn't it? Yep. So if we now look at some fractions squared and that, and we've seen some of these before. But if you were asked to get a half squared, okay, that would be a half times a half. 1 over 2 times 1 over 2. And please always write your fractions with the fraction bar horizontal. Not like this, 1 over 2. Please stop doing this. It doesn't help in math hardly at all. Okay, so 1 times 1 is 1. 2 times 2 is 4. So that is a quarter, right? So if you were asked then, okay, well, and do the root, or what's this then? Please do this one by yourself. 1/3 squared is 1/3 times 1/3, right? Which is 1 times 1 is 1, 3 times 3 is 9, 1/9, right? Can you do this one? 3/4 squared. So it's parenthesis times parenthesis. So go ahead and do this one. 3/4 squared is 3/4 times 3/4, right? 3 times 3 is 9. 4 times 4 is 16. Okay? So the point is, if you were asked what is the square root of 1/4, in other words, what times itself gives a quarter, what would you say? What times itself gives a quarter? 1/2, right? So the square root of 1/4 is actually 1/2, because 1/2 times 1/2 gives a quarter, right? Something that you need to remember too is some people like to do this. Root of 1/4 equals root of 1/2. That is completely wrong. That's not true at all. Square root of a half is not the same thing. Root of 1/2 is different than just 1/2 on its own. The square root of 1/4 equals 1/2, not square root of a half. Okay. You know, and some people, they'll say, okay, root 16 is, and they'll think, well, it's 4, right? Root 16 is 4, but some people, they'll write root 4, but your root 4 is equal to 2. You know, I mean, that's not the same thing. Root 16 is equal to the number 4. Square root of 4 equals the number 2, right? Once you take the square root sign goes away. You can't, that is not correct. Square root of 16 equals 4, and the square root sign is gone. Square root of 4 is 2, and the square root sign is gone. So write this down. What is the square root of 81? Write down the answer. The square root of 81 is, the square root of 81 is 9. Is the square root of 81 equal to the square root of 9? Is that true or false? Well, the square root of 9 is 3. So that can't be true, right? That's completely wrong. Okay? The square root of 81 equals just 9, not root 9. Okay? Okay, sorry. So on this one, what is the square root of 1/9 equal to? What times itself gives 1/9? What number multiplied by itself gives 1/9? So it's got to be 1/3, right? What number times itself gives 9/16? Root of 9/16? Well, 3/4 times 3/4, right? So 3/4. How about this one? What number times itself gives 25/64? Any idea? It's a fraction, right? Take a wild guess. Just take a guess. What do you think? The two tops of the fractions have to multiply to 25, right? So what times itself gives 25? Well, it's got to be 5. 5 times 5 is 25. What times itself gives 64? 8, right? 8 times 8 is 64. So root of 25/64 is 5/8, because 5/8 times 5/8 would give you 25/64. So what's this one? Root of 1/49. Write down the answer. It is 1/7. Okay. Now, just quickly, you might want to review this. 1.7 all squared. Can you figure this out without making a mistake? It's parenthesis times parenthesis, right? So it's going to be 1.7 times 1.7. And can you calculate that correctly? 1.7, 1.7, multiply. 7 times 7, 49. Carry the 4. 7 ones is 7 and 4 is 11. Placeholder 0. 1 7 is 7. 1 1 is 1. Add 9 8 2. And where does the decimal point go? Okay, so we have how many decimal places do we have in the problem? We have got 1, 2, so we need 2 in the answer. 1, 2, right? So to point 89 is what 1.7 squared is. 2.89. So please do this one yourself. 2.1 all squared. Press pause on the video and do it yourself. Okay, so press pause and try it. Okay, now I'll do it. That's 2.1 times 2.1. 1 times 1 is 1. 1 times 2 is 2. A 0 placeholder I need. 2 times 1 is 2 and 2 times 2 is 4. And 1, 4, 4, right? Is that right? Let's see. And we need 1, 2 decimal places in the answer. 1, 2. So 4.41. Okay. Okay. So let's go to page 2. And if we'll calculate these examples here. Okay. If I was doing 5 multiplied by the square root of 49. First of all, if 5 is written beside that, it means times that. And the funny thing is, when you write a number beside something, it automatically means times. So this is kind of like writing 5 times 3 in parentheses. That would be 5 times 3, 15, okay? Or if you just went 5a, you would be saying 5 apples, or which is the same thing as 5 times an apple. Or if you had 5b, that would mean 5 times a banana, right? 5 bananas is the same thing as 5 times a banana. There are 5 times a banana on the table. That's another way of saying there are 5 bananas on the table, right? Anyway, so 5 written beside this means 5 times that, okay? And it's different if there's a plus. If there's a plus, that's not times, obviously that's plus. So this is times, this is plus, right? So there's a difference there. And here's a minus, right? Anyway, okay, so what we do with this is we go ahead and calculate the square root of 49, which is, what times itself gives 49? 7, right? And now we have 5 times 7, which is 35, okay? So if I was doing 4 written beside 100, what would I do with this? What would the answer be here? It's 4 written beside root 100, so it's 4 times that. And the first thing I have to do is actually calculate what root of 100 is. What's root of 100? 10. So I have 4 times 10, which is 40. Now, can you do this one, please? 3 written beside root 1. Figure this one out, and this one. 2 written beside root 81. So please, if you need more time, press pause on the video. Press pause on the video and figure it out for yourself. Okay. Figure out both of these examples. Okay. So did you press pause and try it? Okay, I'm going to do it now. Root 1. The square root of 1 is, what times itself gives 1? 1. And 3 is written beside it, so that means 3 times that. So 3 times 1, and that's 3. Okay. This one, 2, it's 2 times root of 81. Root of 81 is 9. 2 times that is 18. Okay. And just remember, once again, the common mistake people make is they say root of 81 is equal to root 9. Is that true or is that false? Root of 81 is 9. It is not root 9. You okay with that? Just make sure you don't make that mistake. Okay. So basically, when you take a square root of something, then the square root sign is used up, and you don't need it anymore. Okay. Anyway, so if you're doing this one, how would you do this one? Root 121 plus root 36. What would you do here? Any idea? You've got to calculate the roots to begin with. Okay. Like, what's root of what times itself gives 36? 6, isn't it? What times itself gives 121? We had a whole list of those earlier. Remember those? Listed them all out, didn't we? 11 squared is 121. Remember that? Okay, so it's 11. 11 plus 6, 17. Okay. Now, can you calculate this one? 4 root 4 minus 3 root 9. What will we do here? Well, we've got to... we really need to think about PEMDAS again, don't we? Order of operations. We've got to multiply these guys and then subtract. But in order to multiply them, we have to actually calculate the roots first. If we don't calculate the roots, I can't do anything, right? So what is square root of 4? What times itself gives 4? 2, right? So I have 4 times 2. And then minus 3 times, and what's the square root of 9? The square root of 9 is 3. Okay. So now I multiply and then I subtract, right? Because of the order of operations, PEMDAS, right? So we multiply, 4 times 2 is 8, 3 times 3 is 9, and then we subtract. Whoops, and I gave you a subtraction that can't be done. 8 take away 9. Well, when you get to negative numbers, it can be done. What it is if you have $8 in your bank account and you take 9 out, you'll be in debt by 1. So the answer is actually negative 1. Anyway, don't worry about that. You won't see those very much. You won't see those in your homework. Okay, 5 root 64 minus 4 root 16. Please press pause in the video and do this one yourself and see if you get the same answer as me, okay? So please press pause and try it yourself. Give yourself lots of time. Do it. Take your time. Okay, I'm going to do it now. You ready? Hope you've tried it. Make sure you try this before you see me do it. Root 64 is... what times itself gives 64? 8. So we have 5 times 8 minus 4 times, and root 16 is just the number 4. Not root 4, just the number 4. Okay? So 5 times 8 is 40. 4 times 4 is 16. And 40 minus 16, I guess you could do this if you like. 16, subtract. We need to borrow a 10. 10 minus 6 is 4. 3 minus 1 is 2. 24. Okay. Okay, moving on to this last page 3. Are these equations true or false? What are we going to do with this? Any idea? Well, let's calculate the left-hand side and then at least try to calculate the right-hand side and see what we get. Okay. Root 25 is 5, isn't it? Plus, what's root 36? 6, isn't it? And 5 and 6 is 11. So this left-hand side is 11, and what does this work out to be? If this is also 11, then the equation is true, otherwise it's false. So 25 and 36. Add those together. You see, this is saying that you've got to add the inside and then get the root. Does that make sense? Add the inside and then get the root. So 6 and 5 is 11, carry the 1, and that makes 6. So this is root 61. Now, root 61, does that give 11? I mean, we know that root 121 is 11. Okay, so root 61 is certainly not 11, right? In fact, root 64 is 8. So this is 7 point something. 7.8 something or whatever. It's actually a decimal number, okay? So these things are not the same. Okay, we didn't get root 121, and so these are definitely not the same. So this thing is false. Okay, this is not equal to this. Okay, all right. Now let's check this one. Is root of 25 times 4 equal to the square root of 25 multiplied by the square root of 4? So we'll calculate the left-hand side, then calculate the right and see if they're both the same. So to do the left-hand side, we've got 25 times 4 inside of a root. So if I multiply 25 times 4, what do I get? What's 25 times 4? We should know this off the top of our heads. Think about cents in a dollar. Quarters in a dollar. It's 100, isn't it? What's the square root of 100? What times itself gives 100? The number 10, right? So this turns out to be 10. Now if I calculate this, I need to calculate root 25 and then calculate root 4 and then multiply. Okay? So what is root 25? What is the square root of 25? What times itself gives 25? The number 5, right? What times itself gives 4? What's the square root of 4? 2. Okay? So what's 5 times 2? 10, isn't it? So are both sides the same? Yep. So this statement is in fact true. So this is interesting. I can't, if I'm adding, I can't just put a square root over an addition like that. But I can put a square root over a multiplication, and I can break it up as well. So I can kind of split up the square root when I've got multiplication, but I can't split up a square root when I've got addition. Okay, that's not going to work, right? It's not going to it'll change the value altogether. But this will keep the same value. So that's something that you'll see later on. Okay, root 4/9 equals root 4 over root 9 question mark. Let's see. Let's figure out the right hand side. What is the square root of 4? On the top of the fraction here. It's 2. And what's the square root of 9 on the bottom of the fraction? It is 3, right? Now if I was to get the square root of 4/9, I'd be asking what times itself will give me 4/9. What fraction multiplied by itself gives 4/9? Can you answer that? Well, it's got to be 2 times 2 would be 4. And 3 times 3 would be 9. So root of 4/9 has to be 2/3, right? So when I calculate the left and right hand side of this, I get the same thing, don't I? So I can, when I have division, I can split up the square root. When I have multiplication, I can split up the root. But when I have addition, I cannot split it up. And also with subtraction, you can't split it up either. So you'll see that too. Okay.